Hello everyone, welcome back to the channel. Looks completely different in here, huh? That's because I've been working my butt off for the last 7 or 8 days. But I do have progress. Just look at the oscilloscope here. I've got my leads hooked up here and here, negative and to the signal carrier, which this is supposed to be 5 volts positive, negative, and then the signal, but that's not how I've got it going. I've got it running in different pulses and different lengths of pulses with my pulse width modulator here. It's just an Arduino Uno. I'm feeding it through this H bridge, and all 3 phases are just as follows. The white wires go to the gates, so this is the positive high gate on the N channel. This is the negative low gate for the P channel. Okay, the red wire is my positive input, the black wire is my negative input. Pretty simple. The orange wire comes over here and goes to the motor. It's the exact same way on all 3 bridges of this 3-phase H bridge. Okay, and I've just got the gates ran over here to my Arduino, and I've got it set up. I've got the coding set up, right? Well, actually I'm missing 1 step in between each of the steps to get, if you'll notice, you can hear it and it's click, 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 click. It's not really making the sound that I want to hear. And if you'll look at the waveform here, you can see exactly what's going on. And I'll have the code fixed really soon. Let's see here. Let me stop this. Alright. Alright. Spread the wave out. Zoom in a little bit. And you can see it right there. I know you guys can't tell what's missing, but I can see it. There it goes. High, medium, high, low. It's not supposed to do that. See, I went through this website, and let's see here. This is all my coding. I don't have it put up. But I went through this website and I deciphered all the code, and this is what I come up with. Three would be the third bridge, 2 would be the second, 1 would be the first. So on the very first coding, I got 3 high, 2 high, and 1 low. On the very second one, now there's 6 for each step, and I'm missing a step either right here or right here. I haven't studied it long enough yet, but you'll notice it goes 1 and 2 high, and then 3 low, 1 and 3 high and 2 low, 2 and 3 high and 1 low, and that's these. So this will be 1, 2, and 3, 4, 5, and 6. That's 6 gates. And the way I've programmed this, it's really consuming my brain. If that's how you want to put it. It's using every bit of my mental capacity to decipher the way the magnetic field moves inside the motor against the magnets with the coils, firing pulses into the coils. Now, if you'll look at this, let me get my voltage meter here. Okay. Alright. Let's see if I can get all this in the frame. I'm sure I can. Oh, there we go. Alert. Okay. Let's see here. Up to 20 volts direct current. Alright. So, let's do this first. We've got our positive and negative. I'm just using a little 9-volt battery, and I've got 5.3 volts. Okay? Now the input right here on this motor is, oh, what's going on? It's not even showing an input. Let me show you why. It's not direct current, it's not alternating current. Uh-oh, I've got problems on the homestead. Yep. See, the alternating current's reading 1.3 volts. Let me pause it. Okay, so anyways, back to what we were working on here. My tablet turned off. I hate this thing. It's beaten, it's broken, busted up. If it's not plugged in, it won't stay turned on. My computer that I'm writing code with, hang on, I'll get the screen to come on here and just, oh, you see it flash? Oh, it flashed. Yeah, well, I can point light at it real bright, and then I can see it, so I'm working with some, oh, no. Oh, it's on. It's on. Nope. Anyways, I'm not gonna mess with that all day long. Okay, let's see here. Alright. And my voltage meter. Looks like I'm picking up RF. Yep. Just get it over here away from everything. Alright. So, alternate current. We've got 0.03. That's what about 300 milliamps. 0.021. Yes. Now this is a 9-volt battery. This thing will literally run all day long. All day long. And it'll never kill this battery. The only thing that happens is the battery gets a little warm. But the reason why it's getting warm is because while it's charging, while it's consuming, it's also charging. So, with that being said, if you think about it like a transformer, okay? You've got, let me just kill this. Alright. So you think about it like a transformer. You've got a coil coming in on the bottom and coming back out. So there's 2 wires on the bottom of the transformer. You know what? There we go. I'll just grab a transformer. How about that? Okay. And that doesn't have the wires showing. Okay. Here we go. Alright, there we go. Okay. Think of this motor like a transformer, except it has 3 coils. Okay? 1 coil, 2 coil. Oh wait, let's just say this is the 3rd coil. Okay? So you pull positive and positive into this one, and you're shooting this one with negative. Well, what's going to happen? The positive is going to go through the air, through the magnetic field, and into the negative. So you're shooting positive here, it's going to do the reverse, and it's going to shoot it into the negative down here. So you're not, that's how, so we're not defeating the laws of physics here. We're basically using a motor as a motor and an inverter, or a transformer, at the same time. And that's why we're not consuming any power using these 3-phase motors. Now, don't get me wrong. It is nothing easy about this, okay? First thing is, let me find my mouse. Hang on. Alright. Okay, first thing is first. You've got to initiate your pins. Okay, I've got pin 8, 9, and 10 of the Arduino in the program as P11, P21, and P31. Okay, pin 5, 6, and 7 on my Arduino is initiated INT as P11, P20, and P30. I could make that whatever. I could be Bill, Dave, and Barry, you know, and it would pick up down here what it is. I'm just, or I could do the same thing, you know, P8 equals 8, or, you know, pin 11 equals, you know what I'm saying? Okay, now I've got my digital delay down here, which right now it's 1.486. That goes back to my mathematical equations here. There we go. Let's see here. Uh-oh, I've got it wrong. It's 14, 8, 9, 3, 4, 7, 6, 2, 8, 3, 7. That's it. And that's your hertz. You gotta have, people, everyone's saying 15,000 hertz. Technically, it's 14,893 hertz. Okay, and I used vortex-based mathematics to get all this equations, and I had to do it for my particular motor, which has 16 magnets and 12 coils, which is all divisible by 3. And if it wasn't, well, the magnets are the other side of the spectrum. So where your coils have to be divided by 3, your magnets have to be divided by 2. The number 1 is also the number, well, 1 is a sequential. It's either on or off. But number 12 is also number 3. 2 plus 1 is 3. It's really weird the way you have to do the math. And when you do the math for your equations and everything, you actually get all the answers to everything. It's like right here, it's 0.75. That is how many amps I'm going to draw off of this. My capacitance has to be 44.680. I mean, it's, you know, and then you divide that by 3, and that gives you your hertz. It really, the way it all works out, it's really crazy. You got to use pi because everything in nature is either multiplied or divided by pi. So I got to take 12 coils. Well, you know what? I don't want to get into everything right now. I'll be here for the next hour. We're at 15 minutes already. Most people are not going to watch 3 minutes of this. But, anyways, I just wanted to give you a little diagram right there, show you how I was getting my math. Here's how the system works. This is everything right here. Okay? You got your signal coming in, your pulse width modulator, 3 phases. I run at 50% duty cycle. I only want to use the top portion of the sine wave to power it, because if it has to use the top and the bottom, then I'm using twice as much power. And I can use the top part of the sine wave for the positive and then hit dead center for the negative. And I'm just happy with that, and everything else is just happy with it. It's not really AC current or DC current into it after the bridge. It's a signal. So you got your pulse width modulator powered by a 12 volt battery. It's really a 9 volt, a 6 volt, anything will power your PWM, from anything from 3 volts to 12 volts or 16 volts. Some of the things you can use, go up to 24 volts. But anyways, you don't need anything like that, because your pulse width modulator, all it's doing is feeding the gates to your H bridge. Now you may have to use a small transistor to amplify the signal to get your gates on your H bridge the voltage high enough to fire those gates on there, depending on what MOSFETs you're using or IGBTs. But like I said, you have to have 3 N channels and 3 P channels. You can do it with 6 N channels, but then you're using some diodes to direct the flow of traffic. You've got your H bridge, it's 396 volts, it's going to consume 0.75 amps, and we've got 14,893 hertz going into your H bridge. Okay, your H bridge is going to come down to your motor. Most have 45 microfarad. Most, like my self-excited generator head, has got a 45 microfarad capacitor, run capacitor, which is just used as a voltage regulator. It also builds a little bit of capacitance, and it keeps the generator excited. On this motor, it's going to be using basically the same 45 microfarad capacitor. Okay, this motor is going to be, I'm saying a minimum of 45 horsepower, but it's probably going to be more than that, because it is a lot bigger. It is a lot bigger than that little bitty RC car motor that I've got sitting over there. And this thing right here, once I get it wired up, it's going to be something else. So, okay. So we've got happy smiley face right here, because we're running a couple of generators that's running our house. And those generators are going to go to a battery charger that is going to charge this battery, and it is going to charge this battery. Okay, this is the battery charger from the 10,000 watt generator. It's going to go down here to an inverter, so you don't have to use a transformer to, well, you will, because this inverter, it depends on what voltage you get and everything, but it's just going to change DC to AC, and then you're going to use the full bridge rectifier to smooth out that AC and rectify it back into DC. I know, why are you going from DC to AC to DC? It's because I want my direct current a certain way, and that's why I do it. That's why I showed you guys that other motor that was only consuming 2 amps, and it was supposed to be consuming 15 amps. I put a load on it as hard as I could, and I think it went up to like 4 amps. So, and it should have, easily should have went up to 15 amps. So, got our 12 volt battery. That way we always have power on our pulse width modulator. Don't have to, but it'd be a lot easier. We've got another battery over here. We could use the same battery that we're using here. Battery charger, whatever you want to, however you want to look at it. The inverter isn't going to draw anything. I've added everything up all together, and the whole system is going to consume less than 1,000 watts, right at 700 watts, which is nothing. Considering you're making 20,000 watts off of this. So let me zoom out here so everyone can get the whole picture. This is what everybody's been wanting to see. And this is the reason why this video is going to cost money. I do apologize for that, but I tried to do a giveaway with no success, and I'm just going to pick out a handful of people, the ones that have donated to me more than once. Usually I get $5 or $10, but there's a few people that actually donate $100 and $200 to me like every few months. So that always comes in at the right time, which is the reason why I've got new clips. I've got this quad H bridge here. I've got the signal generator here. A couple more Arduinos. I've got parts for my boards. I've got a new bag of resistors. I've got some test leads, some jumper wire test leads, whatever you want to call them. I've got plenty of small transistors, spare parts, a belt, spare parts. But this money that I'm getting from everyone, is every bit of it is going towards these projects. I'm not out blowing this money on stupid stuff. You guys, I am spending this money wisely and very sparingly. And the expensive parts come from televisions and stereos and microwave. And this is what I use to get everything out, because it takes me 3 minutes to get this board out. I get me a nice flyback transformer. I get plenty of capacitors. I get relays. I get big resistors. And I get these integrated circuits here. MOSFETs. I get infrared receivers. Resistors. Ceramic capacitors. Fuses. Bus bar. I get everything basically right here, but it takes me a while to desolder everything and get it off, and that's why it's taken me so long to make these videos. But if you give up, you'll never accomplish it. Never. Now, you see how easy that H bridge was? Look, I mean, it was simple, right? It's simple. That is a simple little circuit. There's 1, 2, 3, 4, 5, 6. That's it. And then 1, 2, 3, 4, 5, 6. 6 gates, 6 transistors, or 6 MOSFETs. Okay, here's the circuit for it. Did y'all get that? Are you going to be able to put that together? Because that doesn't look nothing like this. Nothing at all. Heck, let me show you another one that's even easier. There you go. Simple. Very, very simple. Positive, negative, that's where these two went. You got your three-phase motor. A, B, and C, or 1, 2, and 3. Or 10, 20, 30, and 11, 21, and 31, like I've got it on my programming. You can do it however you want to do it. here's your gates. This one and this one, this one and this one, this one and this one. If you'll notice, this 3-phase H bridge is using all NPN and no PNPs. Is that what I've got here? No, because when you use this right here, you cannot control your BEMF, your backfeed, your back electronic magnetic field. That's what they like to call it, but it's a field that comes from your transformer, well, from your motor, basically like a transformer, coming back in to your battery. And they like to control that. I like to let it recharge my battery. Or I can reroute it, which is what I'm going to do. I'm going to reroute it so that it goes into, it's like these two and these two are firing. I'm going to have the voltage that's coming out of this one going into something else, because these gates will be off, so this will be free to move wherever I need it to. And I'm gonna rewire that, and I'm gonna change that a little bit. It's gonna take me just a little bit of time, but I'm gonna teach you guys how to build a controller for a 3-phase permanent magnet or a 3-phase field magnet motor. All 3 of these wires together means it's wired in star. And here's your other 3 wires, the other side of your coils, which will be your input. And if you use these, crap, I'm turning my phone. Let me do it like this. Alright. Okay, you've got 3 pieces of wire on your stator around the outside. See your stator wires right there? Okay. Your rotor in there has 1 wire on it. That 1 wire comes out right here. Here's one end of it. Here's the other end of it. Here's 1 wire. The middle one is another wire. And the end one is the 3rd wire in this alternator on the stator. So a total of 4 wires inside this alternator, and that's it. Now, this alternator can be, well, the word alternator is the same exact word as the word generator. There is no difference in the word. But a 3-phase generator can also be a 3-phase motor. You don't even have to modify it technically. You can use the same signal that's coming out of one to power one, but that is not efficient. That is not going to get you an 800% efficient motor. Doing it like this will. See, I'm going to amplify the signal coming out of that Arduino, and I'm going to pulse it into here. Now on this side, I'm going to put some diodes so that the current can't come out, or the current can't come out, but it can go in. That way, when the back EMF is coming out of this wire, it'll be feeding to a battery. So all 3 of these will go through a diode and then to the battery. So while I'm pulsing this and powering this, it's actually going to be powering the battery back. And yes, probably going to put a 250 volt, I would say 2200 microfarad ceramic capacitor. You want to go with something at least something like that, and to make this self-excited. You could pull the voltage off of the coils, feed it into a ADR, But, you know, then we're back to generator side again, and I don't want to get back to that. So I'm going to finish wiring this. I'm going to finish fixing all of this, and we're going to change the world. And I can't believe, honestly, that I spent hours building this beautiful little circuit here. Spent a lot of time on it. I mean, even the board in there is the same distance from the plastic all the way around. I spent a lot of time on this, a lot of detail on this signal generator. This is a pulse width modulator. This is a pulse width modulator. Same thing. You know, I said to everybody that's donated to me, I'm going to give this away. I'm going to do a drawing. You know, anybody that's donated for every $5, basically, gets you one ticket entry. Since I said that, I've gotten not one single donation. I was getting a donation every day from people. $5 here, $10 there. What happened? I tell you I'm going to give you something, so nobody else is going to help me out and donate? I don't know what happened there. How could me giving something away stop people from trying to help us? The channel needs help. I spent all the money that come in. I really did. I bought a power inverter. These batteries, they're not cheap. Go look up how much a 1,000 cold cranking amp battery is. You're not going to find one for less than $129. And that's how much these were. $129 before tax. Okay. Now, once everything's running, I've got this. I built a power supply. It's just a variable voltage. You got 3 volts, you got 6 volts, you got 12 volts, and you've got a negative 12 volts. So here's your negative 0 volts, here's your negative 12 volts, then you've got positive 3 volts, positive 6 volts, and positive 12 volts. So, I mean, that power supply, it's really gonna come in handy when I go to wiring everything up, because it's 250 watts. It'll control almost everything on there. It'll keep the batteries charged up for most of the circuit. And I've got a power inverter that's 750 watts. It's going to be hooked to one of these batteries. And the other one is just, probably going to use that right there to charge all of it. Well, no, that won't charge it all, but I've got a battery charger that puts out 10 amps, and it'll never use 10 amps. The whole system cannot consume 10 amps. It's just not possible. Yeah, I started smoking again. Quit smoking for a whole year. Burnt my leg, caught the house on fire, and oh, you want to see that? Oh, you're lying. Whatever. There's the scars. Well, I actually gave up and just laid back and thought I was going to pass out and die. And you can actually see like the marks of the flames coming up right here. It's pretty nasty, really. But whatever. You know, it's just a little burn that went all the way from here to here. Of course, it's on both legs. Which this side healed really good. It was only like 2nd and 3rd degree burns. It burned all the way down to the. Anyways, that's not what we're talking about. We're talking about technology. We're talking about how can I get the funding. I want you guys to help me come up with a way, help me think of a way to come up with the funding for this, so I can start giving these away. I mean, if you'll buy the motor, I will program these for everybody. I don't care. I will sit and program an Arduino for everybody out there that wants one. And I will charge you exactly what the thing costs to buy and ship. That's it. What's my time worth? My time is worth love. That's it. That's all I'm asking. I asked and begged for money before, and this would have been done a year ago if I would have got the funding, but, the world doesn't work that way, and I understand that now. So, give me a little bit more time, and I'll have the code, I'll have it all completed, I'll get this sequence right, and I'm missing one thing. I'm not exactly sure what it is yet, but I'm missing one pulse in there somewhere. I'll figure it out. It only took me about 10 or 15 minutes to figure this code right here out, and programmed it in there, uploaded it to my board to run my H-bridge that runs my motor. Now the input on the H-bridge right now is just a little 9-volt battery, but it's not going to be. I'm going to, this exact same H-bridge right here, I'm not going to plug it into the wall, but I am going to plug an extension cord into the wall. I'm going to add 4 diodes to create a bridge rectifier. 4 bridge rectifier, because I'm going to put a 2200 microfarad capacitor on there as a smoothing capacitor, and then I'm going to add 2 run capacitors on the other side to hold the capacitance so that I don't consume any amperage. And anybody wants to know why I did it like that, that's the reason why I built that circuit this way.